Good morning, everyone. So, our topic for today is about managing product and service operations. So, first, let's define product operations. It is a set of interrelated activities that are involved in manufacturing products. Production or operations management is about the transformation of various resources into value added product or services. But in today's world, production or operations management terms are quite often used interchangeably depending on the product, but a major focus on production operations is on efficiency and effectiveness of processes. So the use of quality concepts with production operations includes substantial measurement, analysis of internal processes, which will be discussed later. So as an operations manager, your objective is to build a production system that identifies and satisfies the customer needs. In this topic, our main objectives is to define quality. Second is to describe the quality revolution. Third is to discuss some of the tools of quality. And fourth is to recognize the methods of work measurement. Assuring product quality. So quality, it is described as fitness for use or customer satisfaction. So quality is divided into two categories: the quality of design and quality of conformance. So first, quality of design is defined as a fit between products or services design and customer needs. Kining quality of design is important because, example, if you're a customer, it's impossible nga mapalit ka na nga butang product or services if dili na siya haom sa imong needs. Second is quality of conformance. It is defined as a fit between the attributes of an actual product in its specification. So, in other words, quality of conformance is about how well a product or services or system is. Kaning specifications, this is the interpretation of what the customer needs. So, product specification, dapat mo fit ni siya sa imong product attribute. Because, for example, sa cellphone, tsada kay mong spec sa cellphone. Example, 8 GB RAM, 5000 mAh ang battery, but baga ra pud siya kayo, like dili siya makarry niya sa nga gagmay og kamot or kanang lapad ra pud kayo siya. So it's impossible nga maka-create gyud siya og customer satisfaction. That's why in order to satisfy customers, quality should be high on both dimensions. In assuring product quality, we also need to consider the quality cost. This is important step in getting management support for improving quality. There are four categories of costs to help analyze the quality provided by the American Society of Quality. First is prevention cost. It is any expenditures incurred that are intended to minimize the number of defects in products and services. This includes quality planning, training, data analysis and reporting, process control, and motivation programs. Second is appraisal cost. It is the cost that a company incurs to detect defective inventory before it is shipped to the customers. So this type of cost is about the cost during inspection of the parts and materials that will be used in production process, whether ang supplier memo test or ikaw when you receive your parts and materials. It also includes the cost during maintenance of your test equipment. Third is internal failure cost. This cost is associated with defects found before the customer receives the product or service. So this includes rework or the cost of making defective items fit for use, including necessary retesting. Also downtime and yield losses caused by defects, and the cost of material review and disposition of defectives. Fourth is external failure cost. So this cost is the cost incurred due to product failures after they have been sold to customers. Examples for this type of cost are warranty cost, cost of return, and cost of return and replacement. When these total quality costs are added up, they total far more than management realize, often of the same magnitude as the total company profit. Typically, the prevention costs are found to be a very small percentage of the total. When a concerted effort is instituted to develop a comprehensive quality program to find the primary reason for failures and to modify design processes and employee training and motivation to minimize failures, savings in failure costs are commonly many times the cost invested in prevention. So this is actually true because if imong workers is highly equipped, mas less sila na commit og errors. So dapat makita dayon ang root cause sa failures to save from failure costs. So kani nga chart shows a relationship between the quality cost and quality level. So based on nga chart, according to Mereno, company must consider modern approach of continuous improvement of product design and of processes used in manufacturing to make it possible to approach very close to 100% conformance without excessive prevention and appraisal costs. Another way of assuring product quality is through statistics of quality. So it is used to evaluate some quality characteristics such as the diameter of a hole, the weight of a package, or the tensile strength of a metal strip. It was developed in the United States in the 1930s and 1940s, largely at Bell Laboratories. However, they received their most intensive application in the Japan after World War II as a result of visits of the American statistical quality control experts Deming and Durant at the invitation of General Douglas MacArthur's occupation forces. So there are two types of statistical methods that are used in quality control. First is variables methods that involve measuring the quality characteristic such as the hole diameter on a sample of an item being controlled, then using a continuous probability distribution such as the normal distribution for analysis. The second method is the attributes method that involve counting as defective those items that do not fall within a stated specification, then using the fraction defective in a sample in discrete probability distributions such as the binomial or Poisson for analysis. Each probability distribution is described by a measure of central tendency or the average and a measure of dispersion, which is the spread. For example, consider a hole with a specified diameter x of 1.250 positive or negative 0.010 inches, i.e. holes from 1.240 to 1.260 inches will meet specifications. So assuming that this diameter was actually measured as 1.235, 1.245, 1.250, 1.256, and 1.259 inches in a sample of 5 items. Using the variable approach, the mean value term as x bar would be found as the sum of these n values, that is 6.245 inches, divided by the number of measurements, n is equal to 5 or 1.249 inches. So using attributes approach, makita ni mo dayon kung unsang measurement ang wala nasulod sa required specifications. Based sa required specification, the measure of the holes, that is from 1.240 to 1.260 inches, 1.235 inches wala siya ni meet sa specifications. So now the sample would then be assigned a fraction defective p or 1 over 5 or 0.20. So the mean value p bar would then be found by averaging the p values for a large number of samples. So in the variable method, the range or R, which is the difference between the highest and the lowest values in a sample, is also a common measure of dispersion. So in the previous example, the sample range would be 1.235 to 1.259 or 0.024 inch. Ranges are easier to calculate but provide less information per sample than does the standard deviation. By the way, the standard deviation for the previous example is 0.0095. Another way of assuring product quality is through process control charts. In production operations, it is important to ensure that the process is in control, which means that it continues to produce items with unchanged quality characteristics. Process control charts are used to point to potential problems that need attention. Control charts consist of three parallel lines, a central line representing the mean value of the quality characteristic, an upper control line or UCL, normally 3 standard deviations, 3 sigma above this mean value, and a lower control limit LCL, normally 3 standard deviation below the mean. If the process stays in control, 99.73% of all future observations should fall between the UCL and the LCL, symmetrically dispersed about the mean. A great deal can be learned about such things as raw material or operator changes, tool wear, or changes in machine settings by observing measurements that fall out of control limits, bunch on one side of the central line, or follow some other non-random patterns. In this way of assuring the quality of the product, the best software to use for this is the Minitab. So basically, kaning nga way is used to identify if stable pa ba ang process. Kay once makita nimo sa process control charts nanay random patterns, this means nga naay potential problems nga kinahanglan nag-attention. Kay once unstable ang process, there could be a chance nga mapektuhan ang quality sa product. Another way of assuring the quality of the product is through inspection and sampling. So mao ni siyang original method of quality control to examine or determine if a product meets the specification set for it, and mao pa ni siya ang most common method. Inspection may be performed on the raw materials and parts you receive from suppliers. So this is the acceptance sampling on your finished product or on your goods in process. So examination of every item, 100% inspection may seem desirable, but it is often expensive unless it can be done automatically, and human inspectors cannot be expected to be continually vigilant and catch all defects. That's why most inspection is therefore done by sampling lots or per batches of product and accepting or rejecting the lot depending on the number of defectives in the sample. So sampling rules can be developed statistically for each situation, but it is more common to consult an established sampling table. For example, suppose that you were using the common military standard, which is the MILSTD 105E for acceptance sampling by attributes, counting, not measuring, of a lot of 2,000 items, and you considered 1.0% defective unacceptable quality level or AQL. If you look up the normal general inspection level for this lot size and AQL and MILSTD 105D, you would be directed to follow these steps. You can use this first option. So first, take a random sample of 105 items from the lot. Second is accept the lot if it contained no more than 3 defective items. 3. Reject the lot if it contained 4 or more defective items. Then either 100% inspect it, sort out the defectives, or return it to the producer as unsatisfactory. Or you can choose the another option, which is the double sampling alternative. So first, take a sample of 80 items. Second is to accept the lot with no more than one defective. Third is reject the lot with 4 or more defectives. Fourth, with 2 or more 3 defectives, take a second sample of 80 items and accept the lot if the total defectives in the two samples were 4 or less, otherwise reject it. So before moving on to the next subtopic, let's first take a look on this company name, Pulse. In 2001, Pulse Sudden Service, a quick service restaurant or a fast food chain in the East Tennessee region, won both the Malcolm Baldrige Quality Award and the Tennessee Quality Award in the small business category. As the company went through the award processes, they realized that first and foremost, they were a manufacturing concern. So they take raw product, process it, and create a totally unique product. Today, they continue to use the Baldrige criteria to improve by learning from the best current management techniques. The process helped PALS to identify their 7 key business drivers, which is first, quality of product and services, second is hospitality, third is cleanliness and sanitation, fourth is training and development of all employees, fifth is value creation for internal and external stakeholders, sixth is the speed, and seventh is the accuracy. Pulse metrics are nearly unheard of in the food service world. A car served at the drive-thru every 18 seconds, one mistake every 3,500 orders, and customer satisfaction at nearly 98%. So these numbers have become a benchmark or point of reference for food service operators across the country. Total quality management. So this consists of organization-wide efforts to install and make permanent climate where employees continuously improve their ability to provide on-demand products and services that customers will find of particular value. The emphasis on quality is key to managing production operations into achieving excellence in today's global economy. So the focus is on customer-driven standards. As the 21st century begins, the quality movement has matured. The new quality systems have evolved beyond the foundations of early users and now incorporate the ideas of Deming, Taguchi, J.N., Durant, Philip, Crosby, Armand Feigenbaum, and many others, blending these techniques and tools with other tools. Some of these includes the following. So first is affinity diagrams, second is brainstorming, third is Pareto charts, fourth is check sheets, fifth is flow charts, sixth is theory of constraints, seventh will be quality function deployment, eighth will be statistical methods, then the last but not the least, run charts. In the early and mid 1980s, many industry and government leaders saw that a renewed emphasis on quality was no longer an option for American companies, but a necessity for doing business in a more competitive global market. So the Malcolm Baldrige National Quality Award was established in 1987 by Congress to recognize U.S. organizations for their achievements in quality in business performance and to raise awareness about the importance of quality and performance excellence as the competitive edge. So, sa pagkakaroon, the Malcolm Baldrige criteria widely accepted na ni siya around the world as the standard for performance excellence. So, kaning mga criteria, gi-design ni siya to help organizations use an integrated approach to organizational performance management. Actually, these criteria are actually set of questions that focus on critical aspects of management, which is first leadership, second is strategic planning, third is customer focus, fourth is measurement, analysis, and knowledge management, fifth is the workforce focus, sixth is the operations focus, and lastly is the results. So these are the past company winners of this award: Motorola Inc., Milliken and Company, Ritz-Carlton, Eastman Chemical, Concordia Publishing House, Henry Ford Health System, Xerox Corporation Business Products and Systems, IBM Rochester, Solar Turbines Incorporated, and Pal Sudden Service. The Baldrige ISO, Lean and Six Sigma are all performance improvement tools and all share the concept of continuous improvement. The only thing is that Baldrige criteria serve as a comprehensive framework for performance excellence, so they focus on business results as well as organizational improvement and innovation systems, while Lean and Six Sigma methodologies drive waste and inefficiencies out of the processes. And ISO 9000 is a series of standards for an efficient quality conformance system. Overall, ISO 9000 registration covers less than 10% of the Baldrige criteria. There is a similar organization in Europe which is called EFQM, or formerly the European Foundation for Quality Management, which gives the EFQM Excellence Award. In Japan, the Deming Prize, established in December 1950 in honor of Edward Deming of the United States, was originally designed to reward Japanese companies for major advances in quality improvement. So over the years, it has grown to where it is now also available to non-Japanese companies usually operating in Japan, and also to individuals recognized as having made major contributions to the advance of quality. So now let's talk about Taguchi methods. So this was developed by Junichi Taguchi. Usas naka-unique ni Junichi Taguchi among the other fathers of quality is that siya ang pinakaunang ni-integrate sa marketing with his own idea of quality. So, ang main concept ani ni Junichi Taguchi is to change production source at the origin. And then, kani nga change, gamito ni siya sa pag-market sa product. So, one major example for this is Tesla by Elon Musk. So, unsa ilang gibuhat, ilang giusob ang common way nga mag-start ka sa car, which is gamitan siya og gasolina. Then ilang giusob into electricity, then mo na ilang gigamit into marketing. So in Taguchi methods, the first normal distributions of a quality measurement is first narrow spread centered on the specification midpoint M. Second is narrow but off center. And third is wider spread but centered, would therefore be almost equally acceptable. So Junichi Taguchi believes instead that there is some loss to society whenever a quality characteristic deviates from its ideal value. In one common model used by Taguchi, that loss is assumed to be proportional to the square of the deviation from the same target T. T is taken as the specification midpoint, and the dollar loss L varies with the actual value Y, as where K is a cost coefficient. Taguchi emphasizes the need for a continuous quality improvement program to reduce the variation of product performance characteristics about their target values. His methods includes extensive experimentation in which product and processes parameters are varied in a statistical matrix of test. Results are then evaluated using ANOVA, analysis of variance, methods to identify the values that lead to least variation. This test also shows the parameter that cause most of the variation, leading to the most cost-effective design modifications and process improvements. So Taguchi methods began to be employed in the US automobile industry in late 1982, and they have since been widely adopted in that industry and are spreading to other US industries. So that's all. John Floyd Hinaut will continue the report.